All right, Godfrey, what are we looking at?
Well, we're looking at a Huawei phone. This is a smartphone that's geared towards the Chinese market. Unsubsidized, it retails for approximately under $100.
Okay.
And it uses the Synaptics ClearPad 2 series technology. And what we're doing here is that we want to have all the high performance of touchscreen, but we've been working with partners like Huawei to reduce the cost of it at the same time. This is a traditional sensor. It's 2 layers, so we have one layer for transmitting and one layer receiving, and this together detects the touch. What we've done is, working with partners like Huawei, develop a sensor that's 1 layer. So not only is it thinner, but it's a lot more cost effective. And if you look at the visual quality of it, I'm not sure if you can tell from here, but at high angles, if you look through it, you don't have to shine the light through a lot more material, and the optical quality is a lot better. The other thing I want to show you too is our Series 3 phone. This is in the high-end phones like the HTC One X, and this is when people or the phone companies really want the high performance. Let's activate it. This is a competitive phone using a competitive touch solution. Let's give you a quick demonstration. Again, this is our Series 3 is our high performance product. It typically works very well, no problem there. But if we get into tests like linearity, by the way, we're using an application that you can download off Synaptics.com. And this is basically a slug that represents a finger. If we draw a straight line, it's nice and linear. You can see a big difference between a touch solution from Synaptics and a touch solution from Atmel. Now, part of the reason why our touch is so superior is we're able to really get through a lot of the noise and cut to the true signal. Now, another big problem that we are seeing with touch phones is that when there's a high humidity or you're sweating or it's raining out, it really impacts the touch performance. Right now, when everything's dry, everything works perfectly, but if your finger is wet a little, you really see some problems with the competitive solution. As you see, it's reporting a lot of false positives, in some cases up to 4 fingers. But if you go back to our solution, it's tracking true. I'm going to dry this off and pause it for a second. Another big challenge that we have with smartphones today is noise rejection. So in the case of noise sources, noisy chargers are a huge problem for mobile phones. And if we go through it normally, nothing's charging right now, there's no load on it. But if we plug in a charger...
Now, this isn't the stock charger. This
is just an off-the-shelf charger. As you can see here, that noise that's introduced by the charger is really causing false positives with a competitive Atmel solution, and it's really not a good touch solution. But if you charge our phone with it, it's no problem at all. We've analyzed the noise source that comes in through the charger, and we've neutralized it, and it becomes a really good experience.